Good evening, everyone, and welcome. My name's Ted Kesik. I'm a faculty member here at Daniels, and it's my privilege to coordinate the Building Ecology, Science and Technology lecture series. It's in its 6th year. Hard to believe how fast 6 years go by. It's been a wonderful 6 years, and the idea behind this was to focus on specialized topics of interest to design professionals by inviting leading researchers and practitioners to share their perspectives on the emerging intersection between ecology, science, and technology in the built environment. I wanted to, at this time, extend my sincere appreciation on behalf of Daniels to Tremco Roofing and Materials for sponsoring this lecture series for the 6th consecutive year. Without their support, this event would not be possible. Getting to the housekeeping part of this, most of you know this, but some of you may not. This lecture qualifies for 2 hours of OAA structured learning credits, and there are these coupons that you can fill out and leave with our staff, and we will process certificates and get them to you as soon as possible, but not until this semester is largely over, because we have, as all of you who are in this profession know, reached those final few weeks of chaos in the semester when everyone is working to get their projects done in time for year-end reviews. So because the students help us do all of this, we can't be too hard on them. We have to wait until they're done, which is only fair. Before introducing this evening's speaker, I'd like to invite Sean McCallum of Tremco Roofing to say a few words.
Thanks very much, Ted. I'm excited to be here for all of the obvious reasons, but in particular, unlike every other time I've got up here, I actually have something to say today. Something I can actually provide some value for you guys beyond the obvious things. So again, Sean McCallum, Tremco Roofing and Building Maintenance. What I want to just mention to you guys, I've got a whole bunch of these invitations here. We just sort of finalized everything and sent out the invitations today to all the people we know. We're going to be hosting a seminar, a building science seminar, April 28th and 29th in Toronto, April 28th at our facility in Leaside, product demos, a variety of different innovative roofing designs and products, solutions, services. But the big one that you guys would probably be most interested would be on April 29th at Ontario Place, Atlantis Pavilion. Full day seminar, learning credits available. I'm just going to run through quickly the agenda with you guys to give you an idea of the quality of speakers we've got at this event. It's a full day event. We've got Professor John Straub talking about white roofs and parapet walls. We've got the University of Toronto's own Scott McIver talking about the Grit Lab and exactly what they're studying up on this very roof, as well as Rick B.E.S.T, who I believe has spoken at this event in the past, talking about innovation in vegetated roof technology. We've got Tarek El-Khatib from Zeidler Partnerships. He's going to be doing a case study on the Union Station revitalization project. We have got a gentleman by the name of Michael Cohen who's going to be talking about innovation in drone technology for building envelope asset management. We've got Sven Lovato, who's one of Tremco Roofing's own, talking about innovation in roof life cycle costing. We've got from Arizona State University, a gentleman by the name of John Savicki, who's going to be talking about innovation in construction procurement. And last but certainly not least, the man, the myth, the legend himself, Dr. Ted Kesik, is going to be hitting cleanup, talking about better building science. So, I mean, just a phenomenal sort of agenda that we've got put together. We sent the invitations out today. We've got over 100 people registered already, so we're really excited about the event. So afterwards, as always, you can find me at the bar. I'll have a whole bunch of invitations there. We'd love to have you come on out, and we look forward to seeing you at that event, and then hopefully again next year at this event. So thanks very much.
Thanks, Sean. You always forget to mention to these people that these seminars are absolutely free, right?
Oh yeah, absolutely free.
They're absolutely free. You just have to show up and enjoy yourselves, and it's a lot of fun. Always a great time. Well, I get to have the fun part and the privilege of introducing the speaker. So Daniel Pearl is a friend and colleague. So many of us hold in high esteem for his design ethos. I would say that we all know him for that in particular, or a whole bunch of other great reasons as well. This year's Building Ecology, Science and Technology lectures covered the topic areas of building, science, and technology, and this fourth and final lecture is really about ecology in its most important sense, that of architecture and how it supports culture, social ecosystems, and human values. In the work of Daniel Pearl, the passive and enduring aspects of architecture are a medium for fulfilling such deep aspirations. It is my pleasure to welcome Daniel Pearl to this evening's lecture as one of the many celebrations of this 125th anniversary of Canada's oldest school of architecture. Welcome, Daniel.
Thank you very much. It's a privilege to be here. I have a lot of good colleagues here in Toronto, and it's rare that I get actually to lecture in my mother tongue of English, since I teach and work in Montreal in French. And it's a pleasure to have many of the people here in the room come to visit us in Montreal. And recently we had Joe Lopko come to Montreal to launch our book, which I'll be showing in a few minutes. So I'm very grateful as well for the people here. It's very interesting. What does really Passivhaus mean? And I guess for me, this slide speaks so much to that, is if we're not going to embrace a more passive, more durable, more long-term, profound thinking, then we're going to be left to counting on some of these geoengineering experts to try and address climate change. And I don't know about you, but I'm not so crazy about this artificial volcanic haze costing $700 million a year to help somehow hold off the warming effects of greenhouse gas emissions. And I think that it's no longer a threat. It's really a reality. And then there's another, at the same time, kind of from an anthropological, historical perspective, a really beautiful writer, Ronald Wright, wrote a wonderful little book, A Short History of Progress. And he tracks the Roman Empire, the Maya, Mesopotamia time, and he shows how there's a history of us understanding the ramifications on our ecosystem and destroying ourselves at the same time. Thankfully, many of these earlier epochs did not have a global effect. And his point is this time it will, because of the scale of the work. And what's fascinating in the book, the thesis of the book really is there's no technological hurdle stopping us from changing and doing things properly. It's really a series of values and somehow allowing those values to surface. As a half-time academic, I do a lot of my research on net positive development at the community scale, the neighborhood scale, moving up to the city scale. That's not tonight's lecture. You have to come to Calgary if you want in June. I'll talk about that then. But it is driving us because the definition of net positive development is not simply ecological. It is a cultural, social, holistic vision. And I think that trying to understand these processes, closing the loops, must include the cultural and socioeconomic components. So it may be an ethos that's beautiful, but there's actually an economics and a whole holistic understanding behind it. And so in that research, what's fascinating is we do have a couple of tools out there. One of them is ecological footprinting, which doesn't really cover the sociocultural, socioeconomic. And one is the carrying capacity, which really is kind of, how dense can we get without it becoming a diminishing returns. And so we're trying to find this sweet spot between the two. And really it's going to be from a transformation of a lifestyle and understanding the local context that we have a chance of activating this, in my opinion. And this research is really fascinating. It goes on with the Urban Ecology Agency of Barcelona, amongst others. The whole notion of social cohesion with complexity, urban metabolism, capacity, and they all have to come together. I thought I'd start the lecture for how many people in the room have heard me lecture on Benny Farm? Great, so it's not too many. So I'm going to just very quickly move through the last 20 years of our practice. I don't really like when I see the name Daniel Pearl. Really, LUF is I started with my classmate Mark Padubiak 22 years ago, and we have a wonderful team. You'll see a couple of pictures of them in a minute. But we're really like a collaborative, and as my spouse would say, or my wife, a non-profit organization, not on purpose. It's not by design, but that's where we are at the moment. We're trying to change that. It's not an easy change. It's probably like climate change. It's not an easy change. And so I thought over the next few minutes, as I kind of describe our last 20 years, to show where these two new projects I'll talk about tonight are coming from. And so yes, we've always done research. Been a half-time professor at University of Montreal for the last 15 years, but I used to teach at McGill as a sessional for 10 years or so before that. And the team has always had a mixture of practitioners and academics and researchers, and our top students have often ended up working at our firm. And there's been a constant change and a constant standard. And the standard really has been the values, and the change is just the natural change in life and people over time. So you have on the top left corner, you have Sudhir Suri, who's now a partner at LUF, and Bernard here on the right, and a bunch of employees, and the partner who started LUF with me, Mark Padubiak here in the middle, who's now become a full-time professor at University of Quebec in Montreal. So we were very generously given an opportunity to co-write a book, which is not an easy task, and co-edit the book, in which I thankfully finished this past summer, and I recognize how much work it is. And then we decided to have this wonderful event to celebrate it, and the Canadian Centre for Architecture invited us to have a dialogue on what is the future of socially inspired housing in Canada. And Joe Lopko and Florence Porte were invited and very graciously came to join this conversation. And we had over 100 people show up from all walks of life, from contractors and developers to students and researchers and activists. And I think that kind of describes the kind of people we work with and the quality of life we have. The exchange really comes around to understanding that the success of a community is going to be really its affordability, its grassroots movement, its activists, finding some equilibrium amongst them all. And I think that that really came forth in the discussion, and thank you once again, Joe, for wonderfully participating. So in those first 20 years, we were always fascinated by this kind of series of complexities, whether it's high-tech, low-tech, this technical innovation, and at the same time, yes, those are my dad's bamboo poles that I borrowed as we built this motoring system in front of the Canadian Centre of Architecture about 15 years ago to try and somehow bring the outside inside and the inside outside. And we work in this integrated process on a constant basis, and most of the people, or many of the people around the table, are not architects, and that makes our work really rich. Our social activist roots really come from the community. There's a lot of women, semi-retired, semi-working, who donated a hell of a lot of time during some of the most critical moments of the history of Benny Farm 20 years ago. And they really taught us how to be activists and how to be effective in our activist activities. The government was going to destroy a real strong, rich community because a bunch of bean counters had an idea that demolition and reconstruction was fine and economically better. So it was a 20-year battle, which is not tonight's lecture, but it's in the book, and you'll be able to download a copy of the book off the internet. I'll show you the website in a second, so anybody can read about this story. The story does deal with everything from the embodied energy, the human scale, how to renovate, add, the importance of common spaces, and how to slide them into projects even when they don't exist in our budgets. trying to find a way to, bring a whole wide eclectic variety of clients together, from single mothers who are still teenagers and going back to school, and they should be in the heart of these communities and not in some segregated parts of the city. And how can this density also really hold on to the values of green spaces within the city? How can we, look at embodied energy as an opportunity? It's rare that we get to do, wood flooring and affordable housing, and this is one of the techniques on how to get that done. We work with a wonderful array of people, so this is part of Claude Commier's design at Benny Farm and our building in the background. And just a very interesting way of finding a happy medium. We can never really easily afford in affordable housing hot water radiant heating systems, but if you recuperate them and reuse them, all of a sudden they can become affordable. And shared space is really at the heart of many of these projects, especially right on the street, to activate them, giving them a quality of life to seniors in this particular project at Benny Farm. There's environmental quality. We're very interested in one of the best geothermal approaches, but at the same time, there was many lessons learned at Benny Farm. In some ways, Benny Farm possibly was too advanced for some of the affordable housing organizations to handle the maintenance and operations. And I think that our second major project that started about 5 years after Benny Farm, mostly designed at least, so this is around 2005. Another wonderful site, an old industrial warehouse yard site that the city used to own. And apologize for a couple of the slides not working. What changed here is, instead of bringing the project right to the forefront and being as green as possible on day one, Benny Farm was designed to be about 50 to 60% greener than the average code housing project, which social or affordable housing wasn't even meeting at that time. And here we decided to only go to 35, 40% better than energy code, but allow the product to grow over time. And that was absolutely critical. And critical because it meant at the beginning maybe it wasn't as complicated, but also it allowed the client to appropriate what technologies they wanted to take over. And we're now finishing a 1-year monitoring period of this project, and it's performing at exactly 40% better than energy code. Surprise, surprise, it actually works. Well, not totally. If you live on the top unit, you're at about 80% better than energy code. If you live on the ground floor, you're at about 10 or 15% better than energy code. So it's not perfect yet, and it's not totally even, and we're still trying to figure out how to modify that. But there are some technologies that worked and never have a problem, including clotheslines. And the geothermal system in general has been very robust, and it's been robust in a sense because we've had backup systems that allow us to do maintenance without actually shutting down our main supply. And possibly the most important part of the project at Rosemont was there was a 3 to 4 year learning period with the client on picking which systems to use. And they basically were at the heart of the vision of the project and not us, which was more the case at Benny Farm. Landscape is never in these budgets, but working with NIP, they found a way, NIP Paysage, to include some components. And the materials themselves are still very modest, but there is a way that they can be passive and beautiful and relatively simple. Yes, some of the wood now is grayed, and some people are okay with that. Others are said it was so beautiful, this torrefied wood, before it started graying. And so there's this constant education on the client. I go back now once a year and give a lecture on, for those people who were not around 6 or 7 years ago when we were first designing, to better understand really, and then also to transfer, because now they're at a point where they're starting to ameliorate the building and add in some of those future components. And so those aesthetic and ethical standards, it's quite amazing to see the client appropriate the project. One of my biggest frustrations, and I'm I must admit I'm a founding board member of the Canada Green Building Council and have been part of LEAD one way or another, is we're not interested in seeing incremental change because in a certain sense there's no time for that. And how does that incremental change turn into quantum change? And it won't be because of technologies, because A, we can't afford it right now, and B, it's not really a good solution around the world. So we're going to have to find a larger transformational approach. But I think one of the hard parts for architects and designers is most people don't really even want to understand how and why their projects are not working. We all want to know why they're working. So I spent a lot of time in the last 5 years doing monitoring plans and post-occupancy evaluations with external experts to try and learn from our projects. And these lessons learned have been at the heart of our latest work, which I'm going to be showing tonight. So yes, we want to see growth over time, but we want to have the modesty to recognize that there's enough robustness and resilience that if some of those techniques are not perfect, that there are other ways of going forward. And I think that we need to have some of that modesty as we move forward. So Ted, you can give away in a raffle afterwards a book I brought for tonight, but otherwise, those who won't have a paper copy, you can go on the internet to our website. At the moment, lift.com has a link to the Wholesome website that you can download the book electronically. It's about 130 pages, so it's...
Danny, I contributed a couple copies to the librarian's Denver.
Okay.
It's here.
Great. Okay. And I think what I like about it is Wholesome doesn't have a history of talking about the lessons learned. It's more about how great the work is. And I was very thankful that Daniel Wentz, the co-writer and from Switzerland, understood how much LIFT wanted to talk about our lessons learned. And I think it's a great source of learning if you don't want to make as many mistakes as us. I'm now going to move into the first of these two projects that are at the core of what I call the next phase of work coming out of those lessons learned. So moving towards Passivhaus. Both projects are exemplary of appropriately applying Passivhaus theory to each scale and context. So after 20 years of socially inspired housing and two major projects, LIFT stepped back in 2012 and reconsidered its strategy for its next major housing project. Can it be more passive? Can it still be cost efficient? Can it be even more comfortable and more even? Can maintenance and operations be as simple as possible without sacrificing short-term comfort or long-term durability? I.e., what if our client has no interest in geothermal energy and the potential headaches or intense involvement in demanding renewable resource installations? After all, many of these people are simply trying to concentrate on the more pressing social and cultural issues in their lives. Is there a way that the majority of measures selected and the design itself surpass the 25-year lifespan asked of these programs required for affordable housing projects in Quebec, while still starting affordable today and even more so over the next several decades? Can we experiment with our clients without treating them as guinea pigs? And then can the lessons learned be shared so that the whole industry benefits and we all can move forward together? That's a little bit of our statement of what we're hoping with this next phase of LIFT's work. So today, no one to my knowledge has attempted an affordable housing towards Passivhaus design at this scale. 166 housing units in North America in steel stud concrete structure. There are fundamental challenges at the heart of Passivhaus thinking that are simply very difficult to overcome with very minimal funds and within dense urban contexts. Air tightness for large-scale 6-story and 13-story buildings is challenging to say the least. Efficient R values for steel stud concrete frames are traditionally R7 effectively, even though there are 25 nominally. Because architects and engineers really don't want to admit this. There's significant thermal bridging, and it's very difficult to minimize it at minimal costs. Requesting or educating residential general contractors to care about the envelope they are building with constant testing is not part of their culture. Designing and installing mechanical HRV systems that are energy efficient, durable, simple to maintain or replace, or where the energy costs are passed on directly to residents instead of being buried in the overall rent, is very challenging, especially as engineers need to work hand in hand with architects to achieve this. Installing windows and doors that are highly performant and well located within protection against overheating that does not require constant maintenance, i.e. kind of movable blinds, is much easier said than done. Solar orientation is most often secondary to urban design principles in the respect of the existing built fabric. And finally, in Quebec, we have a prescriptive program for energy efficiency called Nouveau Climat. It's based on the best that the government thinks we can do with the minimal funds possible available to care about the project. It's simply an incremental improvement on regular affordable housing standards. But most disconcerting, is that it can at the base become a disaster. The existing housing stock in Quebec, dating back to the 1950s and 60s, and like many parts of Canada as well, is quite air leaky, and thus increasing insulation values without overly sealing the existing envelopes will probably not lead to mold, since the seasonal winds will be able to dry out the built-up moisture connected with adding insulation inside the air barrier, which is the wrong location for your dew point. But in new construction, when the government tries to encourage a marginal increase in R values and air tightness, i.e. incrementally, there's a risk that going part way is worse than actually staying as is. If passive house standards are met, then the air tightness and reductions in thermal bridging should provide the resilience and security that the passive house envelope strategy requires, i.e. it should mitigate the risks associated with placing the dew point in the wrong location. If, however, the passive house standard cannot be met for affordable housing budgets, then we, the architects, must find a way to navigate this gray zone. And that's at the heart of the lecture tonight for the first project, this new affordable housing project in Laval, Quebec, just to the north of Montreal. We all know about, in Quebec, there's a Agence d'efficacité énergétique, our energy efficiency agency, and they can do a blower door test beyond the triplex. And the social housing programs and affordable housing programs don't allow you enough money to actually hire larger professional teams. So I actually had to turn it into a pilot project to bring in the people who actually do blower door testing for 6 to 12-story buildings and call it something new. We've seen many of these photos before, and yes, they're energy losses, but I think really it's when we make them so airtight that they actually can become very dangerous. And architects' lawsuits coming up in the next 10 to 20 years will be related to this subject. So architecturally, the building and the form was almost predetermined for us by the technical resource group. And what we convinced the government to allow us to do is on the Y pavilion, which is all seniors, to really go as far as we can towards passive house. On the X, which is for families, about 6, 7 stories, we go further than normal, but we take very, very specific measures to not take any chance with our dew point. And then the Z is for seniors as well. And relatively similar to X, but maybe with a bit more caution and resilience. So within the same building, we tried to set up 3 specifications. And what's fascinating, because at the same time that I asked for a special 6 or 7% budget, which is half that of some of our previous projects, more than the regular affordable housing project, is I've gotten in place enough money to monitor 12 of the units, where 2, 2, and 2 will be in different locations at the beginning, and another another 12. There'll be almost 24 possible total units, but 12 pushed very far, in which maybe there's 6 in the Y and 6 in the X and the Z. And this will allow us, and you'll see what these measuring means. It's really putting thermometre, these sensors, thermal sensors in the wall, looking at humidity, temperature, and really trying to understand how we progressively move towards something and what kind of air tightness we have along the way. So at the same time, the design starts the charrette with passive solar principles. We have this southeast, southwest challenge and can't do anything about it. So this is our southwest facade. And also in affordable housing, we really don't have the luxury of easily putting in mechanized sunblockers. So we're trying to figure out how can we deal with the very hard subject of overheating, because we don't have in Quebec any money for air conditioning, unlike Ontario for our affordable housing projects. And at the same time, we have all this cold and we need all this solar gain. So there's very, very specific studies done very early on the angles and understanding the difference between southwest and south. And it's funny, after the contract came in on budget, actually, thankfully, a company approached the general contractor to put in a mechanized external blind anyway. And we had to fight the client to say, listen, when you start adding in the maintenance operations over the next 25 years, and you put in the replacement costs, it's going to cost you more. And you're going to be looking through this without any clear views for a large part of the time on the southwest facade. And then you've got the ice and issues we have in Quebec and Montreal in particular, and the wind problems. And in the end, the client backed down. But every single way along the way, we have these challenges. This is one of the details that we drew up at LUF for CMHC back in 2005. And it's a wonderful detail. I mean, basically it shows your foundation wall with continuous insulation. But when we tried to build this at Benny Farm, the contractor said, I'm not signing this. If you want 100% liability to hold up 3 stories of brick, even though our engineer said there's no problem, you better write us a special letter and take over. And I don't know how many architects are comfortable about that when the contractor wants to back out. So we did look for this kind of funny kind of precast block that has styrofoam and concrete mixed in, but they don't really perform that well. And so there's always this very nervous thermal bridging at the foundation detail. And thankfully for this next project, we found a product, this foam glass, that can take the weight of brick and still be very affordable. And so really it's our rigor of finding these technologies that are not overly expensive and finding which ones are the right ones to try and incorporate. So we all know about holding up brick. So we have brick only on about 25% of our facades because of the huge thermal bridging problems, and it costs us so much to try and address these issues. So we have a lot more metal siding than normal, but this is really important for the thermal comfort of the client. Yes, this was a detail that we drew up about 10 years ago, but now with the technology of understanding 3-dimensional thermal bridging issues, it's not a perfect solution either. And there's a series of solutions out there. The one on the right is obviously the best, comes from a Europe technology, and especially if you use stainless steel. But we found something local that seems relatively interesting. Just a kind of interesting person with a lot of experience, and it's all, you pour it all in one piece at the slab, and you can have all this adjustment, and then you put in this kind of material that, because we're not doing any welding, it's all about bolts. There's not a danger of the fire as we try and address this thermal, this break in the thermal bridging. We'll be testing it out to see how effective it is, but this is what we can afford on the project. Probably the biggest problem, and Ted has probably shown you enough photos of these radiators where literally the balconies in concrete are one of the worst things possible. We all like to draw these nice thermal breaks, but in the end the steel goes right through, and that steel is very expensive and causes a lot of the thermal bridging. There are the technologies of thermally broken concrete slab extensions, and we know them. They're from Europe, but we don't have $3,000 or $2,000 a unit to be able to do this. We tried a homegrown solution on Benny Farm, and it partially worked. We were lucky enough to have hot water radiant heating in the floor with the geothermal, but on this product we don't have that budget. And so with the innovation of working with the engineers, we've come up with a new strategy, and that is to replace the stainless or the steel with fiberglass rods, about almost an inch thick, that they use on highways. And then the engineer did some testing at McGill and found out that the elasticity and the fragility is actually a real problem, that it could actually snap to, there's no creep in the fiberglass. And so we designed in a kind of a safety mechanism. You can little see it here. It's basically, it's like a stainless steel guy wire that would stop the snapping and give you a minute to move out of the way before it fully falls. And that, assuming that you had an earthquake of some sort, that, it's not going to fall regularly. But I was very impressed by the engineer, Franz Noll, Nicolas Chatronol, to come up with this innovative way, because in the end it costs about a quarter of the European system, and that's what we can afford on this project. The other interesting thing is studies going on across the country between RDH and Morrison Hershfield are showing that the thermal bridging effects on a project are getting 2 to 3 to 4 times more important as our buildings become more and more airtight. And adding more insulation is somewhat useless if it's not being properly added. And this has led to us not going to full Passive House standards on the insulation on a steel stud concrete building. We did a study with Kurt Hepting, a wonderful engineer, Enersys out of Vancouver, BC. And in the end, after doing all the simulation, we've added 5 inches of mineral rock wool outside of the air barrier, so there's zero risk of your dew point in the wrong location. Then we found the technology, very simple, using fiberglass to somehow suspend that mineral rock wool in the wall, and also then have the attachment for the brick ties without having the thermal bridging going right through. Now, we were nervous that this was going to be over budget, and to our surprise, so far, it came in on budget. We'll have to see. It's under construction, the project. And we even included in this affordable social housing triple glazed windows towards Passive House standards for windows. But we picked our locations, mostly on the northeast and northwest. And on the southwest, we have good quality double glazed windows, which could take advantage of the solar gain, and still the air tightness and the proper installation of the window in the right location. So with steel studs, you often have your window in the wrong location on the stud. And here we found this kind of fiberglass section that we actually connect to the side of the stud to try and place the window closer to align with the insulation so that we have less of a thermal bridging problem. Again, we'll have to see how our industry responds to this, since it's not typically part of what they do. One of the hardest things really was working on the mechanical systems. The lessons learned at Benny Farm and Rosemont is sometimes we can have the best systems, but when the costs are centralized, because we have these massive HRVs that are centralized, people on the upper floor, when they get a bit hot, instead of trying to help solve the problem, they open a window. And when they open a window, 2 things happen. A, we lose the energy, and then B, they imbalance the kind of pull of the neutral pressure plane and make the lower units colder. And so we decided that there'll be a central preconditioning of the fresh air using a solar wall, which is a very low technology of just sun hitting a black surface and preconditioning. And so we preconditioned the air essentially to -5, from -20 to -5. And then we circulate the -5 air in the building to all the units. And each unit has a regular HRV, like your typical. The typical HRVs work very well at -5. They don't work very well at -25. And they don't require much maintenance. And so the bill for paying that heating from -5 to +20 is going to be for each individual unit. So they're going to be encouraged not to waste energy. And that's the key. And then secondly, on the upper stories, the top 4 floors of both buildings, we put little kind of alarm contacts in all the windows. And instead of an alarm going off when someone illegally opens the window in the middle of winter, which is not really a very socially, culturally good thing to do, the information is registered in a program, and I promise to go for the first few months and look at the program results and talk to the people about their comfort and what's happened when someone opened a window. And we can figure out how many at the beginning are opening windows, and then just through education and being careful to your colleagues living in the same building, possibly change the way things work, which is really the way old buildings used to work before we start to mechanize everything. So interestingly enough, we expect to get to about 40% better than energy code once again without any geothermal. And it may take 20 years to recuperate your money, but these products we expect to build over 50 to 100 years. And then the other problem I have with this payback is it's always based on operational costs. This design is designed to be durable with no mold and no problems of where your dew point is over time. And that's something that's never put into those pro formas. And that's something that I consider as a problem and why we're not building properly today. But we also looked at values for the client. We put up energy efficiency, but we put up comfort, durability, and resilience. And we looked at every one of the items that were possible to add. And it wasn't a kind of cost engineering. It was about client input on what's important to them within the risk management of the overall envelope. So I don't know how well everybody knows the whole jargon with kilowatt hours per meter squared, but in Quebec, in Montreal or Laval, where it's pretty cold, a regular affordable housing product uses about 240 kilowatt hours per meter squared per year. And our design will get that down to about 134. So it's actually quite a significant drop, even more than the energy savings per se. And we expect to do this with, again, as I said, about 6 or 7% additional funding over our regular affordable housing projects. And what's critical, within this money, because of the scale of the project, we put aside $100,000 during construction to really care about the building process. So about $30,000 to $40,000 is to hire a commissioning agent on the general contractor's team, so that he can't say he doesn't understand this technology, that he has an expert working for him to help him pre-plan everything, and it's already, everybody had the same cost when they were bidding. Then we have about $60,000 of air testing, of thermal bridging testing, of water tightness testing, going out throughout the entire year to guarantee that we move towards 0.9 air changes per hour. Our regular affordable housing projects have trouble hitting 2 air changes. So we're talking about more than 50% or more than 100% better in response. Passivhaus standard goes down to 0.6, which we didn't think was possible given the affordable housing budgets. But then we put in these sensors all over the wall, inside the unit, in order to learn as much as we can of how many of these thermal break techniques are actually going to work, and how can we actually make sure that there's no problems in this approach that we still consider a form of testing. And then we'll be looking at air quality and daylighting and surveys, exactly as we're completing now at Rosemo. It's a really big team. I love organizing it, but this is certainly not a 1 or 2 person effort. And so really that's what we're trying, and I'm going to come back to it when I conclude, but I'm going to now move to a parallel project that was occurring at the same time, and the lessons learned going back and forth between the two. So just like I showed you the history of our 20 years of testing on Benny Farm and Rosemo, here's a couple of homes that I had designed and got built for family members over the years. So this is back in the late 80s, a beautiful project in the woods, very, very low amount of glazing on the north facade. And that's a photo about 6 months after construction. So again, an incredible amount of care to somehow bury the house within nature. And then a second effort, about 10 years later, with a straw bale roof and passive solar principles. Again, very interesting, nowhere near passive house standards, and a lot of passive solar energy, and just a simple palette of materials, and some quirky details on making sure that we don't clog up our drains when we got this combination of compost and straw bales, which is, I actually like this part of the straw bale roof, is it's actually designed to compost slowly over time. And these lessons were important. But we thought that this next effort, this next project we would try, after sporadically designing and building primary and secondary homes over the 20 years on and off, LIFT stepped back also in 2010 and reconsidered its strategy for such projects. We tried to prioritize the following: local building culture and immediate context, passive house design with some active client participation, and promotion of high-quality local products when they are proven enough, or import some to demonstrate why such products should be built locally. Again, we did not want to expose our client to being a guinea pig on something that wasn't yet built here at the scale that it needs to be built. So the site is about 2 hours north of Montreal, so it's relatively cold, beautiful farmlands, and really the client wanted to build a farm, really a functioning farm. So horse, cows, chickens, organic vegetable garden, and a secondary home in which the children and the next generation would learn about those values. And so with Nip Paysage again, this is the site. We looked at some of the history, the movement of the water. These are the wonderful fences that separate the different lines of where the cows graze. And wonderful view of Mont Tremblant in the background. And it's great. They all follow perfect east-west, north-south within 10 degrees. So with NIP, we put together a program for this whole working farm. And it's a really wonderful program. And it's cool that it has activated components in different parts of the year. And if I had more time, I'd go into all the details, but I don't want to keep you here till 9. And these beautiful Highland cows were there actually while we're building the house. So we always had pleasant site visits. And that's one of the cow sheds that was built, designed by us. Simon actually, and from our office, worked specifically on that one. And it's just about how these utilitarian buildings, just like the main house, should come out of the local vocabulary of barns and working farms. You can just see how wonderful they are all year round. And so the site really in the winter and the summer, it's quite pristine. There was no leveling of the site. We worked with its natural topography. And we studied all the components from the winds to the noises locally to the solar orientation, the existing grazing. And we were inspired by many of the barn forms that we found in the neighborhood. And of course, we wanted to bring a modernist effect to it. And I think that really the design is really based on this kind of really interesting east-west axis, which is right on the fence line that you saw in the perspective. And the north-south axis as well. So you end up with these two axes. Sorry, this is the north up. So this is the north-south, and that's the east-west, and that's a total solar exposure over here. And you can see that over here. And so the western part protecting this courtyard is protecting against the west and the southwest winds, which are very strong. And it doesn't stay hot for too long. You have maybe a month and a half of hot weather, and then it's pretty cold most of the year. So this external kitchen and greenhouse actually end up wonderfully kind of protecting this external exposure of the beautiful south orientation of the farmhouse. And then we have to the north of the site all the vegetable gardens and this wonderful orchard that's still young and going through growing pains as we approach the site and come through the orchard, coming down to this axis. And down the axis, you'll see some photos. You actually see Mont Tremblant to the east and the house and the entrance is really at the cross of these axes and then moves into the center. Here's where we have the vegetable pavilion to work on all the produce, and another kind of shed, like now they're actually together. When this plan was done, they were separate. And we have the cow shed down here, and the chicken coop actually near the front of the property. Working with Nip Paysage, one of the techniques that was interesting, the only kind of gesture in the landscape with this beautiful ha-ha wall was to stop the cows from maybe charging the client's more private domain. And so it's a simple wall that's well located, that really followed the natural terrain. And you don't see it from the house, actually, because it's really, you have to go around the back. So it's actually quite beautiful when you do go around the back. And the house really is designed to kind of expand and use different spaces throughout the year. The greenhouse starts the production for the outside. We're just actually using Professor Mark Lesterud's technologies in LED lighting in order to perfect the preparation of the germination phase. So it's the kind of experimental component is being used all around. The produce has actually got finished ahead of the house, which is one of the great things of everything working at the same time. And the wall section, for those who've seen this or not, published in Canadian Architect, one of the cool things about it is if you actually look at the solar gains and losses, the facade itself, the envelope actually produces more energy than it needs during the year. It's really the need for fresh air from the heat recovery ventilator that makes the house meet the 15 kilowatt hours per square meter. So to keep this in mind, the social housing, affordable housing, when it starts normally at 240, if you're in regular housing, we got it down to about 130, and this is at 15. So, you know, obviously it's not the same budget, and it's not the same goals, but I think the principles of what we're learning and passing from one to the other is really where the fun is. And really, this was a project where we really were able to eliminate almost 100% the thermal bridging. This is a funny sketch of mine to try and work with Jean-Marc Velle, a wonderful architect engineer out of Paris, who tried to help us figure out how to actually brace the house, because it's such an open floor plan and it's very, very hard. So it was a very complicated 3D simulation software, and it's actually the mechanical space above the master bathroom that actually helps brace the house, because we have these beautiful views at the entrance and out to Tremblant on the two gables where we can actually totally solidify the house. That makes it a little bit different than a barn. So you can sense those gables and the highly glazed south elevation and relatively quiet north elevation over here. What we really like is the palette of materials is restrained because the lighting and the nature is so amazing. We wanted to give a chance for the flowers and the vegetables and the animals to provide a lot of the color, and the atmosphere. I mean, it's just a beautiful place to go up and visit. And one of the great things about using 150-year-old siding is you don't need to treat it. It's just naturally treated through time. And so you get this old barn look on day one. The stone is local quarried stone. We have a combination of limestone and St. Mark stone. And all of the post and beam that you'll see in a moment are all reused, rehabilitated, and recuperated wood from all the local farms in the kind of southeast of Quebec. Sometimes he goes down to Vermont or Ontario to get some of his supply. And again, very simple, beautiful wall into the landscape on the north-south axis. So the plan is very, very simple. The sections and elevations are actually some of the most beautiful components. On the upper floor, we have a kind of a den or 4 children sharing one large bedroom, or kind of a bridge going to the master bedroom. Kitchen, dining, living in the main space. Outdoor kind of kitchen with its fireplace, and greenhouse over here to work on the germination and flowers throughout the year. You can see in more detail here. Almost no basement anywhere. We only have a mechanical services area and some vegetable storage below. And you can start to see how thick the walls are and all the detailing that comes along. The stacked fireplaces using very, very high efficiency German stove technology, so they don't at least use any energy from the house. But we're finding out that the house, when it's minus 25, is still plus 25. And we're trying to figure out how to stop it from overheating in the middle of winter. It's such a kind of a Ferrari in a sense. And all that we have in the house for heating is hot water in the ground floor where we have our St. Mark stone. And the engineer didn't want to take a chance, and he put hot water in the wood stud with a little bit of concrete topping. But we're finding out that we need to turn it off for most of the winter, that the house is just too effective. We have these beautiful green roofs over the greenhouse and the kitchen and over the entry pavilion, because there's a little external carport. And these are beautiful views you get from the upper floor and the staircase looking at green roofs within the landscape. So on the ground floor, as you come in and you go down the central axis, it's framed by this beautiful view of Mont Tremblant to the east, the southern exposure to the landscape and the courtyard, and relatively well protected to the north, with the main entrance of the day-to-day basis coming from the north, with the pantry and the kitchen right at the heart of the house, where you get to see everything. There's a external shower, there's a hot tub, and the greenhouse, which has triple glazing and high degree of effort to cut some of the energy loss. But as you go to so much glazing and comfort and what actually is required for a greenhouse, I don't think we would be able to get this functioning if we didn't have the assistance of this professor, because LED lighting really can help you with any missing amount of daylight so that you can use the greenhouse all year round. The construction process was a real lot of fun, a certain learning experience. It was fun to go out with our structural engineer and evaluate the wood before we started designing the house to see how we can span the house. It's a lot of fun, and we took the client along, and he said, oh yeah, I want that one, I want this one. And I think that that's needed when you need their support at the more difficult moments later on in a project. And even checking out the siding material before you start designing the external facade. And then this amazing technology now where you can actually build these, we have this insulation that could basically build a slab on grade on top of 8 inches of solid insulation, and it's not moving. Even this winter was our coldest winter. There was a problem with one of the doors a couple of weeks ago, and got a call from the general contractor saying, your house is moving. I told you. And of course we go up there and the house is not moving. There's a weather stripping problem on the door. No, these details are really well thought through. Simon worked a lot on them. It's a lot of effort gone into how to get it done. And even the whole post and beam, like most people don't want to see why kind of pieces in this modernist aesthetic. So you have this interesting mixture of steel and wood, 150-year-old columns that have holes all over the place that deal with all the moment connections, and then the whole technology of eliminating the thermal bridging. It's actually quite an exciting thing watching the structure go up. The treated wood, as much as we need to treat them, not all the sides are going to be exposed. And then very early on, Simon and I, in the detailing of the wall section, we wanted the post and beam to be disconnected from the house, because gyprock and paint and whatever other finishes don't move the same way wood does. And so we brace the structure hidden in a certain sense, and there's some movement allowed, because the external wall are these huge prefabricated panels. And so we can also then hide in blinds if any are needed at any point within the house, and separate the two. And I always felt from Auguste Perret, the idea of separating the column gives you a much nicer feeling in the room than when it's buried within the walls. And it feels more like a barn. We integrated the external shading to not have the overheating, and they're programmable but I have a client here who has the money to repair it, which I don't have on our affordable housing project, if it does have a problem. It's all actually quite cool the way it's programmed. You can program it by facade and then follow the sun and adjust the angles. But if you don't want to use it, that's why we put in extra backup air conditioning using through the HRV distribution. But the house is designed that you don't need any air conditioning if you were to use the blinds properly throughout the summer. You have this wonderful limestone continuing, and the wood. We actually don't connect the wood so that the two structures, one's steel, one's wood, they come close to each other, but they don't actually touch each other. And then we have this wonderful gutter detail that everybody always asks about how we get that done. Not a very obvious thing to get built, but it does look beautiful. But you do need to have, we have put in our suspenders, we have an electric cable in case there is a problem, nonetheless. So the construction really requires a good team to understand how to build with such old wood, the whole bracing temporarily of the structure along the way. And then these huge prefabricated panels that are then bolted onto the post and beam, but with a certain distance. And because this is the warm side of that panel, there's no thermal bridging there. We're able to inspect it all. And then the beautiful kind of light steel mixed in with the old wood structure that Jean-Marc Velle designed. I thought at this point I'd just take a second to just tell you really about the challenges. You know, there's additional consulting costs. There's a challenge with the construction industry. There's modeling and simulation that's so hard to do on Passivhaus. Estimating costs, need for specialized monitoring and testing equipment. But there's some advantages too. We think it's reduced maintenance and operation costs, simple once built, reduced heating and cooling, resilience with power failures, very comfortable thermally, and easy to marry with other passive approaches like thermal mass and natural hybrid ventilation. So this is a kind of showing you, the client let us put in 50 thermal sensors throughout the entire house in the walls. So these are well located, usually under doors or windows. That's the panel delivered with the sensor already in place. And then we actually have a number for every sensor. So I go on the internet and see what's happening. It's kind of cool. And this is really what that sensor is. It's wireless. Should last for about 5 years, which is really what I need to know as far as the functioning of the house going through all the cycles and making sure there's no problems. Because when your walls are like this thick and you have a problem, it takes you months before you find out. And by then, there's too much damage in the house. It's not a very helpful approach. This whole system was $3,000. I mean, if you think of the risk you're doing, this is really the right approach. This is how you would install it, pretty simply. Wonderful mason doing all the beautiful work. Amazing tapes that come from Europe that actually connect wood to steel, wood to concrete, actually expand and contract. One of our big problems with air tightness is we pass our blower door test, but within 5 years, the tapes lose a lot of their stickiness. And so it's very, very important if you're counting on your dew point in the wrong location that you don't take any chances. And these beautiful windows that actually are quadruple windows in a sense. The last external, which has an air pocket, actually protects the automated blind from being damaged in the wind. So it's actually quite nice. And it's just a very simple aesthetic. It took us a lot of work to let it look so simple. And this is the way we support those doors off the foundation. It's not sitting on concrete, so there's no thermal bridging. These are these kind of laminated materials bolted to the side and this massive insulation on the outside. And it's interesting, as heavy and as wood insulated the house is, the greenhouse is built very light. And aesthetically, it wanted to play one off of the other. And I accept that this is where we're being a bit more aesthetic. It's not the perfect design. But I don't think a greenhouse needs to be perfect that way. Plants don't need the same comfort as people. And it's interesting how we're able to deal with that. One of the kind of vegetable garden pavilion in the landscape. This is where we have the generator in case of power failures, which occur all the time. The green roof with the vegetable gardens in the background. The triple glazed greenhouse, which has the advantage of not losing so much energy, the disadvantage of losing some natural daylight, and that's where the LED lighting mixed in brings a happy marriage between the two. It's quite a beautiful experience inside there. I don't really have good photos yet in the greenhouse because we're still modifying and completing it. Some photos with the blinds being tested and used this past summer. They moved in. And all the greenhouse, we have to deal with the overheating, the skylights that open, and wonderful organic farming and gardening, and between Nip Passage and Runaway Creek, really beautiful landscape. I think it was an element that was really key to convincing the client to invest into landscape. So the results of the tests, if I have a lesson to tell anybody on Passivhaus in Quebec, at least in this climate, we monitored the humidity levels inside the moisture content in the wood throughout the construction process. And the east, south, and west walls never went past 20%, but the north wall did. And that's pretty clear, the sun energy drawing out. And so when you cover your north wall, you better be sure that it's got its moisture out, because it's not going to dry very easily when it's so thick. So there's a certain risk factor on the north facade. Thankfully, we have less windows. And we made it up to about 18%, you can see here. And these are my 50 points that we keep on testing and making sure. Since we've closed the house and it's operating, they're never more than 16 or 17, even on the north side. So we have no nervousness anymore. And then the inside is, we worked with an interior designer, Cynthia Adelson, trying to respect as much as possible our modernist with the kind of barn architecture. So you have an interesting marriage here. The modernist staircase, the light is just, it goes right across the room. The house is so thin that you really get beautiful lighting right across. And this two-story height space over the dining room helps with the whole kind of hybrid ventilation. We have these two skylights in the center of the house and two mechanized windows in the top of the bedrooms, so we can get a beautiful natural ventilation going right through the house, and wonderful lighting coming in. There's moments in the house that are magical where you can find little places and feel the comfort of the scale of a barn. I think it's very hard to photograph how warm the house is because it does have a modernist aesthetic, but it feels very, very warm, especially as we move up to the upper floor. Again, all of the wood is 100% recuperated from the floors to the ceilings. A lot of beautiful artwork that the client wants to have in the house, so a lot of effort to how to light that. Looking down towards the dining room from the library, nice little den. There's two TVs in the house and they're both kind of hidden. They're part of our life, but we didn't want them to dominate the aesthetic of the barn. And really, this talks about some of the warmth in the house. So, elements in common between the two projects. Can it be more even and more comfortable? Can maintenance and operations be as simple as possible? Is there a way that the majority of measures selected in the design itself surpass the 25 years? Well, I guess I do believe that these two projects do hold those things in common. They look at thermal comfort, they look at understanding the culture, the climate, the client, and the future. Thank you very much. Please, I'm sure between the flashy photos and the technical details, there must be some questions out there. Yeah?
How did you resolve the issue of thermal bridging of the chimney?
Of the chimney?
Yeah.
Very good question. I'd say that there's a very complicated detail at the chimney that would probably have to take an email answer. What we did is we did break the concrete with insulation. The chimney is not 100% load-bearing stone. It's like the wall outside. The stone is thick, but it's not load-bearing. It's self-load-bearing. And the concrete is the structure behind it. And that concrete is broken right at the point where the foundation insulation goes right through. And then we brace it. And that's it. Good question. I wish my students would ask that.
Hi. Have any of your projects taken advantage of, the natural resources in the area, such as light or wind, in terms of energy generation?
I think this project does. I think the wind in this project is properly shielded on one side and encouraged for nighttime flushing. It's just not turned into a renewable resource. The amount of electricity required in our project is quite minimal. And to add this complexity of renewable technologies would be the antithesis of the simplification of the operation of the house. So we do have solar hot water tubes, evacuated tubes on Benny Farm. There's days when they work and there's days when they don't. And I think that it's a lot better to count on the passive principles and look at the high-tech principles as a bonus. I think the passive approach is more robust. The geothermal systems are robust enough, but they need a dedicated client and a certain scale of a project. And I can't say that they were robust enough 10 years ago, but they are now for our kind of residential client construction in Montreal.
Could you tell me a little bit about the roof in the greenhouse? I couldn't really see from the photographs. I saw what looked like vents, ventilation boxes. But
Yes, those are two different types of vents. We decided to put in these, I guess this lecture could go on for another hour minimum, the details. We decided there wasn't a very good HRV available in Canada yet. So we used a company called Zender out of Germany that has a US distributor. And we found a way to get the engine CSA or the motor CSA approved, even though the unit isn't, for all types of political reasons. Those units are very efficient, and we needed to have an exhaust separately than the supply, so we have our supply and exhaust far enough away. And the HRV in the greenhouse also has an enthalpic core to hold on to humidity instead of a regular core to help keep the humidity levels that are good for plants. Versus in the main house, we take out the cores every 6 months, because another lesson we've learned is during construction, because we have such dry winters in Montreal, the wood could crack a lot during the construction process when you're not properly sealing the house. And we had to add a humidification system because of the artwork in the house as well, to be able to control it with a lot more control. So that humidification system's going through the ductwork that is shared with the HRV. And we're finding out that there's times of the year in a passive house where you could have a lack of humidity, because there's so much wood in the house too, and it needs a lot of humidity. At the same time, you don't want too much humidity because you don't want to have walls with the wrong dew point, and therefore you need the air tightness. So that's why we're doing a lot of monitoring. We're trying to see, we have a humidification system, how it goes. So the greenhouse, I'm less nervous. It's a flat roof. It's a steel deck, green roof technology. The main house is not. It's breathable, upper level but with, massive solid prefab insulation panels, but with a breathable space in between the zinc roofing and the wood strapping.
I still don't buy the passive house standard in the complexity of a multi-unit dwelling, particularly because of the integrated systems, and then the extremity of heat and cold that we face here, further complicated by the fact that it can change 35 degrees centigrade overnight.
I want to give a lot of credit to Frédéric Genet from Pajot Morel and the work that his team did to find the right balance between centralized and individual treatment. I can't say how important that is. It's such a simple solution, but no one's done it that I know of in Canada. So really how it works is there's a variable volume control that goes to every floor from the central HRV. So in Quebec, we passed a law a couple of years ago that allows a tenant to stop getting fresh air when they don't want to be connected to the HRV. And because of that law, we came up with this mixed strategy. So it means that if someone wants to turn off their fresh air, and they can. And as soon as humidity in their unit reaches a certain point, there's an override that the fresh air restarts. And then what we did is we don't use a regular strategy for the 6 and 13-story building. Each unit is neutral. There's no negative pressure in the unit with a positive pressure corridor where all the fresh air goes from the corridor into the unit and out of the unit. But then everybody has a kitchen fan. And when that kitchen fan goes on, you can have negative pressure in the unit. So what we did is we have a special register with a kind of a damper, kind of a smoke damper inside the wall between the corridor and the unit, that it somehow opens when the kitchen fan goes off and pulls some of the slight positive air of the corridor into the unit to keep the unit neutral, to not have any problems with our envelope again. As I say, for me, there's a management that all architects are going to have to do on the science of air tightness and building envelope. Excellent question. Well, I think someone else is going first.
Sorry, just quickly, for projects like this, how do you calculate the cost per square footage to ensure that you're within budget, especially with the experimental sides?
If you're talking about the affordable housing project,
This one in particular.
this one, I can't say we had the same control. I mean, because I'd say the biggest problem on this house was not the passive house component, it was the reuse of materials component. That's the truth. The wood and the imperfection, all the kitchen cabinets, all the built-ins, everything's done with recuperated 100-year-old wood. And that's very hard to have managed. And that was probably the biggest unknown on the project. On our affordable housing projects, our government forces us to separate during the bidding process the additional measures from the regular measures. And we end up, on this particular project in Laval, we did something we've never done before. We actually had an argument with the contractor who said it cost less than what we think it costs. Normally it's the opposite. It was very funny.
With the passive house that you went for this one, there's quite a lot of chain differences between little conventional houses, a little sustainable housing, and your house that you went with, especially with the design. Have you had some difficulty or restrictions when it comes to design parts such as ceiling or like a roof height, grades, and such sorts?
Well, first let me clarify something about this. It's not an official passive house. We started the process of certification, and in Canada, they don't allow you to throw out the stale air of your kitchen exhaust. And our client said, given how amazingly efficient this house is, this seems a bit over the top. So we meet it in every other way but that way. So we did not pursue the organization. We don't think that's the goal, to get into any debates with them. If they think that's important, we think the principles are important to follow, and that's what we've done. So sometimes on this 15 kilowatt per square meter calculation, if you have double height spaces, it punishes your design. Again, we didn't let it punish our design. We used common sense. We got there anyway, but had we come up with 16 or 17, we would have been fine with that too. Thank you.